In this video we are discussing synchronous versus asynchronous execution. In distributed systems, execution models define how processes communicate and coordinate with each other. The two main models are synchronous execution and asynchronous execution. Synchronous execution. In synchronous execution, processes operate in a coordinated manner where time bounds on message delivery, processing, and clock drift are assumed. A process waits for a response before continuing. Characteristics. Blocking communication. Known upper bounds on delays. Easier to design and reason about. Communication is blocking. Easier fault detection using timeouts. This diagram shows synchronous processing between two processes. Process A sends a request to process B and then waits, for the response. During this waiting time, process A cannot continue its execution. Once process B sends the response, process A resumes and continues its work. Advantages are: predictable behavior, easier fault detection, suitable for time-critical applications, predictable behavior due to time guarantees, simpler system design and reasoning. Disadvantages: poor scalability, performance degrades with delays, less fault-tolerant, low scalability due to waiting and blocking, high latency because of synchronization delays, not suitable for large-scale or highly dynamic systems. Asynchronous execution. In asynchronous execution, processes do not assume time bounds. A sender does not wait for a reply and continues execution independently. Unlike synchronous programming, where each task waits for the previous one to complete, asynchronous tasks can run concurrently, utilizing resources more efficiently and enhancing responsiveness in applications. Characteristics. Non-blocking communication. No guaranteed delivery time. High concurrency. Event-driven behavior. Processes execute independently. This diagram represents asynchronous processing between process A and process B. Process A sends a request to process B and does not wait for the response. While process B is processing, process A continues its own execution. When the response arrives later, process A handles it without blocking. Advantages are: highly scalable, better fault tolerance, improved performance, high scalability for large systems, better fault tolerance and resilience, improved system performance and throughput. Disadvantages: complex to design, harder fault detection, consistency is harder to guarantee, difficult fault detection, delay versus failure indistinguishable, harder to ensure consistency, increased complexity in debugging and testing. Thank you.